Okay, let's dive right into this. Welcome to this explainer, where we're going to unpack one of the most massive, dramatic, and quite frankly, suspenseful cosmic mysteries of our entire lifetime. For the past several years, astronomers and casual stargazers alike have just been holding their breath, watching a very famous star act, well, very strangely. We're talking about Betelgeuse, that bright, ruby-red jewel hanging right on the shoulder of the constellation Orion. Today we're going to explore exactly why it suddenly went dark, the absolute panic it caused in the scientific community, and the incredible brand new discoveries that have finally solved the puzzle. So, get comfortable, because we have a truly fascinating celestial detective story to walk through.
Remember back in late 2019? One specific question had literally everyone, from professional astrophysicists to amateur backyard skywatchers, in a state of absolute panic. Is Betelgeuse about to explode? You see, stars like this, they don't live forever, and when they die, they go out in a spectacularly violent event known as a supernova. For a brief moment there, it really felt like we were on the brink of witnessing the greatest astronomical event in recorded history. But to understand why everyone was so completely on edge, we first need to understand the beast we're dealing with.
That brings us to Section 1, the giant in Orion. Let's quickly establish exactly what Betelgeuse is and why it commands so much of our attention when we look up at the night sky. To really grasp the panic, you have to understand the sheer, mind-boggling scale of this star. Betelgeuse is what we call a red supergiant. It's about 16 times more massive than our sun, but it is vastly larger in sheer volume. I mean, if you were to just pluck Betelgeuse out of Orion and drop it right into the center of our solar system, it wouldn't just swallow the Earth. Its outer surface would completely engulf Mercury, Venus, Earth, Mars, and the asteroid belt, stretching all the way out to the orbit of Jupiter. It is this pulsating, bloated, swelling monster of a star that's nearing the very end of its evolutionary life cycle.
Now, the key number to keep in mind here is 650. That's how many light-years away Betelgeuse sits from our own solar system. In galactic terms, 650 light-years is practically right next door, which makes it the closest red supergiant to Earth. But it also means that looking at Betelgeuse is literally looking back in time. The bright, reddish light hitting your eyes when you step outside tonight, that actually left the star 650 years ago, smack in the middle of the European Middle Ages.
Which sets the stage perfectly for Section 2, the Great Dimming Mystery. Let's look at the sudden drop that made the world think the end was near for Betelgeuse. Following the timeline of this mystery really reveals just how confused astronomers were. For centuries, we've known Betelgeuse is a variable star. It naturally brightens and dims in these cycles, most notably a 400-day cycle and a longer, roughly 6-year cycle. But in late 2019, the bottom completely fell out. Betelgeuse suddenly and unexpectedly plummeted to just 40% of its normal brightness. This was totally unprecedented. By early 2020, it slowly crept back up to normal, but the astronomical community was thoroughly spooked. Then, get this. A study in June 2023 suggested that based on its pulsation periods, Betelgeuse might actually be at the very end of its life, with a supernova possible in just tens of years. But as the timeline marched forward into 2024, the data started pointing in a completely different, wildly unexpected direction: a hidden companion. But before we get to that companion, we absolutely have to address what actually caused that sudden, terrifying drop in 2019. The culprit behind that initial dimming? A massive 400 billion. Our own sun occasionally burps out plasma in what's called a coronal mass ejection. Well, in 2019, Betelgeuse experienced a surface mass ejection that blasted off a piece of its visible surface. And this ejection was 400 billion times larger than a typical mass ejection from our sun. No way, right? Yeah, astronomers quickly realized the star quite literally blew its top. That unimaginable eruption of hot gas pushed outward, cooled down, and formed an immense cloud of stardust that physically blocked the star's light from reaching Earth. So, okay, that solved the mystery of the acute 2019 dimming. However, astronomers were still left with a huge, lingering puzzle. What on Earth was causing the star's longer underlying 6-year cycle of dimming and brightening? If the star wasn't dying right this second, what was tugging at it? And this brings us to Section 3, Meet the Betel Buddy. This is where a massive revelation from July 2025 cracks the case completely wide open. Using incredibly advanced speckle imaging on the Gemini North Telescope in Hawaii, astronomers finally managed to peer through the massive glare and directly imaged a hidden companion star. And they gave it just a beautifully poetic name, Siwarha. In Arabic, Betelgeuse is often translated as the hand of the giant, so the discoverers named this little companion Siwarha, meaning her bracelet. I mean, it's a fitting, gorgeous name for a star that has literally been hiding in plain sight, wrapped around the giant's arm for millions of years.
When we actually look at the Beta Buddy's stats, they are fascinating. Siwarha is small compared to Betelgeuse, only about 1.5 times the mass of our Sun. It's a hot, blue-white pre-main sequence star, meaning it's incredibly young. But the orbit is the real kicker here, 2,100 days. That is exactly the roughly 6-year cycle that has puzzled astronomers for so long. And even wilder is its distance. It orbits just 4 astronomical units away, meaning 4 times the distance between the Earth and our Sun. Remember how we said Betelgeuse's atmosphere stretches all the way out to Jupiter? Well, Jupiter is about 5 AU from our Sun. That means this little companion star is physically orbiting inside the extended, bloated outer atmosphere of the red supergiant.
So, you might be wondering, how does a tiny star cause a giant to dim every 6 years? Well, think of Siwarha kind of like a boat cutting through water. Because it's literally plowing through the sparse outer atmosphere of Betelgeuse, it leaves a dense wake of disturbed dust and gas right behind it. As Siwarha circles around the giant every 6 years, that dense wake of dust periodically passes right between Betelgeuse and Earth, absorbing and scattering the starlight. It's not the giant dying, it's literally just its little buddy kicking up dust.
And that realization changes absolutely everything about our timeline. Which brings us to Section 4, the supernova must wait.
The astronomical community is breathing a massive collective sigh of relief right now. And here's why. The old theory assumed that the 6-year dimming cycle was an internal heartbeat of the star, a sure sign that it had exhausted its helium and was in the frantic final stages of core carbon burning. If that were true, the supernova was imminent. We're talking maybe decades or centuries away. But the new discovery proves the 6-year cycle is purely external, caused entirely by Siwarha's orbit. This means Betelgeuse is actually still in a stable, helium-burning phase. The star is safe. It likely has hundreds of thousands of years left before it collapses. So, the crucial takeaway is that Betelgeuse isn't going anywhere anytime soon. But the same cannot be said for its little friend. Because Siwarha is constantly plowing through the thick atmosphere of the giant, it's experiencing incredible tidal drag. In a mere 10,000 years, its orbit is going to decay completely and it will be fully engulfed, swallowed up, and destroyed by Betelgeuse. The bracelet is going to be entirely consumed by the hand of the giant.
Now, I know some of you might still have a lingering worry in the back of your mind. Whenever Betelgeuse does finally explode, whether it's triggered by eating its companion in 10,000 years or naturally in 100,000 years, is it going to hurt us here on Earth? Well, the magic number here is 160. For a supernova to destroy our ozone layer and actually threaten life on Earth, it has to be within 160 light-years of us. Because Betelgeuse is safely part 650 light-years away, we are completely 100% safe from the radiation.
So instead of a cosmic apocalypse, humanity's descendants are simply going to get the greatest show the universe has to offer. When Betelgeuse finally does go supernova, it's going to shine as brightly as a half moon. It'll be so intensely luminous that you'll literally be able to step outside and see a star shining in the middle of the bright blue daytime sky for about an entire year. At night, it's going to remain visible to the naked eye for several years as it slowly, beautifully fades away into a nebula. It'll be a spectacular, totally harmless light show.
Which leaves us with this final thought. Betelgeuse isn't some ticking time bomb ready to end us. It's a dynamic, incredibly complex system. It's a bloated giant with a tiny, doomed companion just stirring up dust in its atmosphere, and it's all playing out right in front of our eyes. So, my question to you is, will you step outside tonight, find the constellation Orion, and just look up at its glowing red shoulder? Take a moment to appreciate this celestial gem, knowing exactly the incredible dance that's happening 650 light-years away. Thanks so much for joining me for this explainer, and hey, keep looking up.